students, today in this video I will tell you that how you can calculate different numericals by using the log tables, because we know in most of the numericals there is the need of log table. There are some numerical values whose log we determine from the log table and we put these values, only then we can solve the numerical. For example, there are so many numericals related to the electrochemistry like Nernst equation or Gibbs free energy or equilibrium constant value. Similarly, there are so many numericals related to the determination of the rate constant in chemical kinetics also. If we move toward the lower classes, we can say in +1 or in the 10th class, there are so many numericals related to the calculation of pH for the acids and bases. So in all these there is a need of log table. But if we use the log table and we determine the value of different numerical digits from it, it takes a long time. Sometimes there are so many chances that we can determine the wrong value also. So here I am suggesting you one method. There is a short method by which you can drive your log table by yourself and you can quickly use it. So in other way we can say you can learn the periodic table and finally you will be able to use this in the correct determination of the answer in the numerical. So this is possible here, and how it is possible I am going to tell you. So let us start with this video. So for this you have to create your own log table like this. So on one side you will have to write log, and on other side you will have to write the table of 3. On one side write the table of 3 and on other side write the log. So here you will have to write 2, then double of 2 is 4. Similarly double of 4 is 8. And similarly you can write further also. If you want more to drive further, you can drive up to 16 or even you can drive up to 32 also. So there is a need of some simple values. That's why I am giving you short trick that you can calculate up to 8 only. Then in front of this value 2, you will write the table of 3, then it is 6, then it is 9, and then it is 12. We know from the table of 3, first is 3, then 6, then 9, and then it is 12. So what you will have to do, so after writing 0, put a decimal here in front of 3. Similarly, put a decimal here in front of 6. Similarly, put a decimal before 9. When there are 2 digits, like here it is 12, so you will have to draw decimal in between the 2 digits. So this is how we can say the value of the log 2, it will come out 0.30, while the value of the log 6, its value will be value of the log 4, it will be its value will be 0.6. Similarly, the value of 8, its value will be 0.90, and the value of 16 log, it will come out 1.2. In the same way, you can calculate the log of other digits in between these. For example, you want to calculate the value of log 3. So what will be its value? You will have to take mean of these two. So what is the mean of these two? If we calculate the mean value, it is 0.3, 0.6, it will come out 0.9 divided by 2, its value is 0.45. So what is the value of log 3? So we will write here 0.45. Similarly, if you calculate the mean of these two values, one is 4 and other is 8. What is the mean value? Then this is 5, then this is 6, then this is the 7. So there are 3 digits in between 4 and 8. If you calculate the mean of these two numerical values, the answer will come out the log of 6. So what is the value of log of 6 here? So in the same way you can add 0.6, 0.9, answer is 1.50, and we will calculate its mean and it will be 0.75. So similarly, you have determined the value of log 6 here. So if you want to calculate the value of log 5, then you will have to take mean of these two, 0.65, 0.60 and 0.75. So again, we can determine in the same way. Here it is 0.6, here it is 0.75. If we calculate the value, it is 1.25. When we will take its median value is here, so it will be 0.675. So the median of these two values, its answer will be 0.75. In the same way, the median of log 4 and 6, its value will be 0.675. Similarly, if you want to calculate the value of the log 7, you will have to take the median of these two. If we are calculating the median of these two, its value will come out 0.75, 0.90, so 1.65. So the median is, here it is 0.825. So the answer of the log 7 will be 0.825 here. Similarly, we can determine the values of the log which are lying in between these digits also. For example, if you want to calculate the log of 2.5, you can take the mean of these two, that is 0.330 and 0.45. So 0.30, 0.45, its mean is 0.75 divided by 2. So if we calculate its value, so it will be here 0.375. So what will be the value of 2.5? It will be 0.375 if you want to calculate further. For the simple numerical, what I have solved here, what I have determined here, it is more than sufficient. So now I am comparing this log table that you have created yourself with that of the actual values which are given in the log table for these numerical digits. So how we are relating these? So let us have the actual values. If we have look over the actual values, in the normal log table, the value of the log 2, it is 0.3010. While here we have determined its value 0.30. So what is the difference? It is the difference over the third decimal place, which is a negligible, or we can say it doesn't matter while we are using the value of 2 in calculating the numerical values. Similarly, if we have the look over the log 3 actual value, its value is 0.4771 in the actual log table. So again, there is little bit difference over the second decimal place. Here it is 7 and here we have determined its value is 5. So it again doesn't matter when we are using this value in calculating the numerical. Similarly, if we have the look over the value of log 4 in the log table, its actual value is 0.6020, while what we are using here, it is 0.60 only. Then if we have look over the log value of 5 in the log table, its value is 0.6989. Again, there is a difference over the second decimal place, which is negligible. Similarly, if we have look over the log of 6 in the log table, its value comes out 0.7781. So again, difference over the second decimal place. Then if we have look over the log value 7 in the log table, its value given is 8450 in the log table. So here we are using 0.82, again the little difference over the second decimal place. So here in the last we have 0.9030 for the log 8. So if we have look over all these actual values and all these we have determined in a short way with a logic, so there is little bit difference over the third decimal place, or somewhere it is different over the second decimal place. it doesn't matter. I'm showing you with example that there is little bit difference when you will use these numerical values and these in different numericals. For example, we are calculating the numerical related to the pH. So we know pH is given by equation that is negative log HN concentration. Suppose you are provided with a solution whose HN concentration is given to you and its value is 2 × 10⁻³ mole per liter. If we put this value of HN into the above equation, then what is the answer of pH? Negative log 2 × 10⁻³ So if we calculate further, so it is log m into n, so it is log 2 plus log 10⁻³ Then upon further solving, it is log 2, I can directly write plus 3. So now there are two possibilities. Now there are two answers. Here I am using on the left hand side the logically created value of the log 2, and on the right hand side we will use the actual value of the 2. So what is the difference in the answer obtained? We are comparing here. So if we are using the logically created value, then it is 3.0 minus plus 3. On the other side, if we are using the actual value, which is 0.3010, so what is the difference in the answer? So on this side, the answer will come out 2.70. So pH is 2.7 if we are using the logically created log table. So if we are using the actual value from the log table, the answer will come out 2.699. So if we compare these two answers, on one side it is 2.7, on the other side it is 2.699, which can also be written as nearly equal to 2.7. So we can say there is very little difference in the answer, which can be neglected here. So this method is very suitable for the calculation of numericals related to the objective question in the multiple choice question, because in so many competitive exams these days this type of numericals are mostly in the exam. So we can frequently calculate these numerical by using the logically created log table. So I am giving you further one more example by which we can compare the difference in the answer by the use of these two types of the tables. So again, we have another solution whose HN concentration is given to you and its value is 5 × 10⁻⁴. If we put this value in the equation of pH, then its answer will be negative log 5 × 10⁻⁴. Then pH is equal to negative log 5. If I directly solve this, then you will reach here negative log 5 plus 4. Then if we put the value of log 5 from these two log tables, there will be again two answers. So now we will compare these two answers. What's the difference? So on one side on the left hand side I am using this value 0.675 minus plus 4. So if we are subtracting this value, the answer will come out 3.325. Similarly, if we are using the exact value on the other side, its value is 0.6989. So plus 4. So the answer here it will be 3.3011. So again, if we are comparing these two answers, what's the difference? So difference is over the second decimal place, which can be neglected. So the actual answer is, we can say the answer of the pH is 3.3 in both the cases if we have look over these two. So this is how we can easily solve the numerical related to the use of log table, which is very frequent method. I have suggested to you to solve the numerical by this. In case we are using the actual log table, it's time consuming and sometimes you may determine the wrong value also. This is the logical way by which you can solve the numerical. So I hope that if you have any query related to this calculation, or you find it difficult in using further in numerical, you can send your comment in the comment section of the video, and I will give you answer of all these by solving in the next video. Goodbye.